All right, so at this point, what we've done is we've now filled in our entire chart with our square of the deviations. We'll come back to our note. So therefore, we will use the mean of the squares of the deviation. So that's what we just filled in our chart. The standard deviation is the square root of the mean of the squares of the deviations. It tells us on average how much the values in a set vary from the mean of the data. Hang on. We didn't use the, but we didn't calculate the mean of the squares. Our column, what we just did on that last page is we calculated the squares of the deviations. So now we've got a series of data and we have to calculate the mean of the squares. Right? What we've seen is that when we have ungrouped data and we calculate a mean, what did we do? Here's our mean. We took the summation of x divided by n. Is that right? Yeah. So at this point, we have to add all of these values. The sum of x minus x bar squared. Well, the reality is some of them are quite easy. We just have one of these, one of these, one of these, but we have two of these. So in order to get the sum of all these, we're going to take the frequency. How many times does that occur? So x minus x bar, and we square that. So in this case, it's the same. 1, 2, 4, 2, 5, 6.25. In this case, it's twice that value. So this is a 3, 2, 5, 1, 2.5. All right, so we need to go through and fill in this chart with all of the data. Anytime I've left my chart blank, it just means that I'm not repeating what's there beside it. Here we get a value.
What operation are you doing to that?
I'm multiplying it. So I have two values here. Yep. So whenever my frequency is 1, it's just the same value as my x minus x bar. So I haven't bothered writing it for the second and the third case. In the fourth case, I've got a frequency of 2, so it's going to be 2 times 16.256. All right, so what we've done, we've got our deviation in a deviation column here, our deviation squared, and then our last column is simply showing our deviations, and here we recognize that 2 people guessed 500, so my deviation squared should be multiplied by 2 to get that value. So whenever we had, remember we had multiple modes for this question, wherever we had more than one data point, we need to represent the fact that those deviations occur twice. And finally, we're told that our standard deviation is the standard deviation is the mean of the squares. So we've calculated the squares, And in order to do the mean, we have to sum them all up and divide. Oh, we're looking at standard deviation, or so we're looking for a sample. It's going to be the sum of our squares, which we've just shown, and then we're dividing it by n minus 1. So the sum of all these squares, if I add up this entire column, gives me 53.7375. That's the sum of that entire column. So we're going to need to use this particular formula to calculate the standard deviation in our set of data. And the difference here is, so n, capital N is the number of data in the population, and n is this number in our sample. So in our question, 20 is equal to n because we have 20 data points. The mean of the squares of the deviations is called the variance and is equal to the square of the standard deviation. So our variance, we don't take the square root of that. There's two data points. There's standard deviation and there's the variance. And so if I simply square my standard deviation, that generates my variance. We'll apply that. So in this particular case, continuing from where we left off, calculate the standard deviation for the set of data in the example. So this was this example, I think, is the data that we've been looking at on the front of our note. So we've calculated that the sum of the deviations was a total of 537,375. We divide it by, there were 20 in our sample, and the formula says it's 20 minus 1. If we put that into our calculator, it generates So this tells us that most of the data falls within 168.18 points. In this case, that would be population from the mean. Really, this is saying we expect the population at the game to be around someone. So this says we expect that we really expect at the game there's around between 460 to 795. Most of our data falls within that range. Now I say most with quotation marks. We'll later find out what that most means, but for now we're